In today's lesson, we'll be learning how to find angles using the cosine law. In our previous lesson, we learned how to use the cosine law. We learned that the cosine law can be used to figure out the side length in an acute triangle. For example, if you wanted to figure out side length A, you would need three things. You would need the angle opposite to side length A, as well as the two sides surrounding the angle. It is important to remember that the appearance of the cosine law will change depending on how your diagram is labeled. For example, this diagram is using the letters A, B, and C. However, if your diagram used X, Y, and Z, you would have to change your formula accordingly. Although the cosine law is primarily used to figure out the side lengths of an acute triangle, you can also use the cosine law to figure out the angles within an acute triangle. So I have angle A, angle B, and angle C. However, you are going to have to do a lot of rearranging to solve for these angles. In our first example, we want to solve for the indicated angle to the nearest degree. The first thing you want to do is take a look at the diagram, or create a diagram if it has not already been provided. 9 centimeters would correspond to side B, 10 centimeters would correspond to side C, and 8 centimeters would correspond to side A. Now, we want to solve for angle A, which means we're going to need a few pieces of information. So I'm going to use this arrow scheme that I've introduced in our previous lesson. That means we're going to need side length A, side length B, and side length C to figure out angle A. Let us begin by rewriting the cosine law according to the labeled diagram we've been provided. So a squared is equal to b squared plus c squared minus 2bc multiplied by the cosine of angle A. There are different ways of going about solving this question. You can substitute in all of your known values, simplify, and then solve for the unknown, which is angle A. Or you can rearrange first and then substitute in your numbers and then simplify to solve for angle A. I'm going to show you both methods today in example 1 and example 2. In example 1, I'm going to substitute in all of my known values immediately. And I'm going to do that by putting these numbers in brackets. You can simplify some of these numbers. So 8 squared is 64. 9 squared is 81. 10 squared is 100. Negative 2 times 9 times 10 is negative 180. Your cos A stays exactly the same. We want to simplify some of these numbers. Let's add 81 and 100. A lot of students will make the mistake of subtracting 180 from these numbers. However, you can't, because 180 is being multiplied by cos A. So you can't just subtract 180. Therefore, the 64 is going to stay the same. 81 plus 100 is 181. The subtract 180 is not going to be used quite yet. Like I've mentioned before, multiplication is happening between this negative 180 and the cosine of angle A, so we can't touch that. What I'm going to do is I'm actually going to take 181 and I'm going to move it to the other side, which means I'm going to be doing the opposite operation to both sides. I'm going to be subtracting 181 from both sides. I am not going to write in all the work for that, and I'm just going to immediately subtract 181 from the left side, and I'm going to remove 181 from the right side. So I've canceled it out. 64 subtract 181 is negative 117. Everything on the right side stays exactly the same. Now, you have to be really careful here. As I've mentioned, there is multiplication between negative 180 and the cosine of angle A. Therefore, to get rid of negative 180, you have to divide both sides by that number. A lot of students will make the mistake of adding 180 to both sides. That would be incorrect. So those are going to cancel out. Negative 117 divided by negative 180 is 0.65, and you're going to be left with the cosine of angle A. Now, I'm just going to rewrite this so the cosine of A is on the left side and 0.64 is on the right side. So I haven't really changed anything. I just rearranged it because we read from left to right. Now, since I'm solving for an angle, angle A, you need to do the inverse function. So you're going to do the cos inverse of 0.64. Remember, you have to use a special button on your calculator. It might be a shift button. It might be a second function button. So since we are rounding this, let's figure out what the unrounded number might be. That is 49.5 degrees. But if I were to round that, that would be 50 degrees. So let's make a concluding statement. Therefore, angle A is 50 degrees. So we've just used the cosine law to figure out what angle A is equal to. It is very important to remember that when you are rearranging these numbers and solving for angle A, that you are extremely careful with adding, subtracting, multiplication, and division. In our second example, we want to solve for the indicated angle to the nearest degree. The first thing you want to do is take a look at the diagram, or create a diagram if it hasn't been already provided for you. So, if I want to figure out angle B, I'm going to need three things. I'm going to need side length B, I'm going to need side length C, and I'm going to need side length A. So again, I've been using this arrow scheme to help me remember what I need for the cosine law. At this point, you're going to rewrite the cosine law according to the letters that have been used in your diagram. So I have b squared is equal to a squared plus c squared minus 2ac multiplied by the cosine of angle B. As mentioned in our previous example, there are different ways you can approach this question. In the previous example, I substitute all of my known values in, I simplified, and then I rearranged to solve for the unknown angle. In this question, I'm going to do the opposite process. So I'm going to rearrange everything first and then substitute in my numbers. At the end of the day, I want to isolate angle B. However, we need to get rid of everything that it's stuck with. So the first thing you want to do is you want to move a squared and c squared to the other side of the equation. And when you do that, they become the opposite operation. So what was once positive now becomes negative. Notice how both a squared and c squared has become negative. Everything else stays the same. It's important to remember that the operation that is occurring between those variables and the pair of brackets is multiplication. Therefore, the opposite of multiplication is division. So you're going to divide both sides by negative 2ac. What happens is the negative 2ac cancels out. And what you're left with is b squared minus a squared minus c squared over negative 2ac is equal to the cosine of angle B. And you notice I've removed the brackets. I no longer need them. I'm going to move everything from the left side to the right side and the right side to the left side, just because it's a little bit easier to read, and we do read from left to right. So I'm going to put the cosine of angle B on the left side, and everything else is just going to move to the other side of the equal sign. All right, at this point, we want to substitute in all of our known values in brackets. So I have 12 squared minus 13 squared minus 10 squared, all over negative 2 multiplied by 13 multiplied by 10. Let's simplify some of these numbers. So the cosine of angle B stays exactly the same. 12 squared is 144. 13 squared is 169, and 10 squared is 100. You'll notice that I'm only squaring the numbers within the brackets. The subtraction signs stay the same. Now over on the bottom, I have negative 2 multiplied by 13 multiplied by 10. You can go ahead and throw that into your calculator, and you'll get negative 260. Again, in our next step, you're going to continue simplifying these numbers. So 144 subtract 169 subtract 100 is negative 125. And negative 260 stays exactly the same down below. I want to divide these two numbers. So cosine of angle B stays the same. Negative 125 divided by negative 260 becomes a decimal. And I'm only going to take a few decimal places. You can take more if you want. However, it's not really necessary. If we want to figure out an angle, you need to do the inverse function. So you need to do cos inverse. I'm going to find the cos inverse of 0.4808. Remember, you're going to have to use a calculator to do this, and you're going to have to use the second function or shift button on your calculator. And that will give us an angle of about 61.3 degrees. However, since the question wants this rounded to the nearest degree, I'm just going to round down, and that's going to be 61 degrees. So let's write a concluding statement. Therefore, angle B is 61 degrees. As you can see, we are still solving for an angle within an acute triangle. However, we are using a slightly different method than our first example. We are rearranging and isolating our angle first, and then substituting in our numbers.